What is entropy in simple terms? Have you ever wondered why things seem to get messier over time? That's a bit like what entropy is all about. Let's break it down in simple terms. Entropy is a way to measure how much disorder or randomness exists in a system. Think of it as a gauge for chaos. When you have a neat and tidy room, the entropy is low. But as things get scattered around, the entropy increases. In thermodynamics, which is the study of heat and energy, entropy plays a key role in understanding why certain processes happen on their own while others do not. For example, if you have a box of air molecules all bunched up in one corner, over time, those molecules will spread out to fill the entire box. This spreading out increases the disorder, meaning the entropy of the system goes up. Now let's connect this to energy. Entropy also tells us how much energy in a system is not available to do useful work. When energy is transferred as heat, the entropy changes. Take melting ice as an example. When ice turns into water, the molecules shift from a more ordered solid state to a less ordered liquid state. This transition increases the entropy of the system. Entropy is closely tied to the second law of thermodynamics. This law states that in an isolated system, which does not exchange energy with its surroundings, the total entropy will either increase or stay the same. This means that certain processes are irreversible. For instance, when ice melts on a warm stove, the total entropy of the system increases, and that process cannot just spontaneously reverse itself. In everyday life, understanding entropy helps us see why energy becomes less useful over time. In machines or engines, some energy is always lost as heat. This heat cannot be turned back into work because of the increase in entropy. That's why no machine can be 100% efficient. To sum it up, entropy measures the level of disorder in a system. It also indicates how much energy is unavailable for work. Entropy tends to rise in natural processes, driving spontaneity. The second law of thermodynamics tells us that total entropy in an isolated system never decreases. Understanding entropy connects the tiny movements of molecules to the larger behavior of energy and matter in our daily lives.